Okay, this is actually a review video for pre-calculus in Unit 8, the third day. So we're going to go over some stuff we've already learned. So let's first start with graphing exponential and logarithmic functions. So for the parent function here, I have my 2 points at 0, 1, and 1 base, and the base is 3. And then we're going to take those y values and multiply them by this -2 in front. So where are they going to go? They're going to go to 0, -2, and 1, -6. And that's where I'm going to start with graphing. You can graph the original parent function points, but I usually don't. Okay, so there's 0, -2, and then there's 1, -6. Okay, now we also have a shift left 4, and we're going up 1. So I'm going to take those points, and in a different color, I'm going to shift them left 4 and up 1. So 1, 2, 3, 4, up 1. Boom. 1, 2, 3, 4. Did I count right? Yeah. There we go. And what else do I need to do? Maybe I should put the asymptote on there. So the original asymptote for this exponential function is at, there's my x-axis, there's my y-axis, is right here. There's the original one, right? At y equals 0. But we've taken this whole graph and shifted up 1. So I'll draw it right here. At y equals 1. And so now we have an idea about where the graph is going to go. We got these 2 red points, and we've got our asymptote, so it's going to have to be approaching the asymptote, and it's just going to go whoosh, exponentially, boom, like that. All right, so our domain is -infinity to +infinity, and our range is from -infinity, we always go to low to high, up to the asymptote, but not including the asymptote, so up to 1, but not including 1. All right, next problem. Our original 2 points for a logarithmic function are at 1, 0 now, and I usually do the reciprocal of 1/2, so I don't have to do, we can just have nice whole numbers. So the reciprocal of 1/2 is 2, and then that would be at -1 rather than 1. So where are those points going? They're going to go right to and down 5. Okay, so 1, 0. Hold on. I guess before I go right 2 and down 5, we're going to take these y values and multiply them by 3. When you will multiply this y value, 0, by 3, you're going to stay with, you'll still have 1, 0. And then 2, -1 will become 2, -3. So maybe I should plot those first. Let me erase this. Okay, so I've got 1, 0. Oh, that's not changing. Shoot. All right, here we go. Oh my gosh. All right, 2 points are plotted, and now we are going to move them right 2 and down 5. Okay, the asymptote has been moved to the right 2, because now this is a logarithm. So we're going to have vertical asymptotes, and then you just draw your graph. And your graph is approaching the asymptote. And remember, these are reflections. Exponential functions and logarithms are inverses of each other, and so they're basically going to be reflected over the line y equals x. So that's why the horizontal asymptotes are changed to vertical, and the graphs are essentially flipped over the line y equals x. All right, moving on. All right, I'm going to run through these examples really quickly, but you can read these directions if you'd like. They're on the sheet as well. But really, all you're doing first is you're switching the x and the y. So you're rewriting the equation as x equals -1/2 log base 4 of y plus 2 minus 3, okay? And we're going to try and isolate that y. So we need to move the 3 over, so that will end up being a plus 3 on the other side. And now we need to do the base. Wait, did I? Oh, I got a. I lied. This 1/2. Let's get rid of that 1/2. Let's multiply both sides by -2. And doing the other side, that's going to become -2x minus 6. Now we just have a log base 4 of a number. Okay, so now log to this 4 to -2x minus 6 should equal y plus 2. So let me draw that over here. I'm just rewriting the logarithm in exponential form. And now we almost have y isolated. We just have to move the 2 over. So that will now have the y isolated. Y should equal 4 to the -2x minus 6, and then, is that a minus 2? I'm getting confused because I moved over it. It's a minus 2. Okay. That's it. There we go. Now the second problem, they're asking us to find the inverse. So I'm going to go ahead and our g of x is essentially our y. So if I rewrite this as switching the x and the y, I would get x equals 2 to the 3y minus 1 plus 6. Okay, so this is going to be x minus 6 equals 2 to the 3y minus 1. Okay, so 2 to the x minus 6. So that's log base 2 of x minus 6 should equal the exponent, 3y minus 1. Logarithms are exponents. All right, so now we have to isolate, let's see, we have to get that y by itself. So log base 2 of x minus 6 plus 1 should equal 3y. And now I'm going to divide everything through by 3. When I do that, I'll get 1/3 log base 2 of x minus 6 plus, and I've got to divide the 1 as well by 3. That's 1/3. Should equal y. Okay, and that's the inverse. So instead of writing y, I'm just going to write the inverse of g because the original equation had a g of x. And so I'm just going to write the inverse of g. And it's asking just to find the inverse, so we're done. All right, let's see if I can do some of this practice pretty quickly so we can finish this video in 15 minutes. So we're asked to write the exponential equation as a logarithm. So that's just log base 7 of 343 equals 3. And this one is log base 2 of 64 equals 6. And I like to check those just by going 2 to the 6th equals 64. 7 to the 3rd equals 343. Now, we're asked to write the logarithmic equation as an exponential. I think these are easier because you just go boom like that. 4 to the 3rd equals 64. And this one is 8 to the 3rd equals 512. All right, now, when you're asked to evaluate the logarithm and find a missing exponent, if you had a calculator, you could just type this in, log base 2 of 32, and it would give you the answer. Okay, however, you're thinking, when you don't have a calculator, 2 to the what power equals 32. So 2 to the, and you just put a little, sometimes I just put a little box there, equals 32. Well, that's going to be 5. 2 to the 5th power is 5. Or, sorry, is 32. So this one is 4 to the what power equals 1 over 16. Well, 1 over 16 is equal to 1 over 4 squared. And that's the same thing as 4 to the -2, if you're dealing with exponents. So 4 to the what power equals 4 to the -2. That's just -2. And this one, 1/3 to the what power equals 1 over 27. Well, what is 1 over 27? 1 over 27 is equal to 1 over 3 cubed, right? So you can either think of that as 3 to the negative 3. I think it probably might be easier to do. All right, 3 cubed is 27. So that exponent that we need is going to be a 3. Because, let me explain that again because that was confusing. Come on, mouse, work. Oh my gosh, why is my mouse not working? Okay. Here's another quick explanation. So, base of 1/3 to the third power equals 1 over 27, does it? Well, if you were to just go ahead and rewrite this as 1 to the third power over 3 to the third power, because they're essentially equivalent, you're going to see that it's the same value, 1 over 27. All right, last one. We have 8 to the what power equals 2. Well, we know that's going to be a fraction, because if I put a number like 2 or 3, I'm going to get a 8 squared. It's going to be a bigger number. We need a smaller number. So what we're really doing is 8 to the what power equals 2. If I rewrite 8 as the same base of 2, that's 2 cubed. I just rewrote 8 as 2 cubed. That's 2 times 2 times 2. Okay, and then kept the box in the same place. Now that the bases are the same, I can set the exponents equal to each other. And I'm just going to say, just call this an x. Say, all right, well then 3x has to equal 1. What's x? X is going to be 1/3. So 8 to the 1/3 power equals 2. And that makes sense because the cube root of 8 is 2. So 1/3. And we're finished.